Hello, everyone. So you're starting a discussion session on system design. So this is not to resemble any interview kind of format, but this is more of like a developer to developer or colleague to colleague discussion on system design. So we'll be trying to go as much as deep as possible into every problem statement. So today we have Karthik. So Karthik was a senior software engineer at LinkedIn. And today we'll be actually starting with some discussions and we'll see how the response comes from you guys, and accordingly we'll decide on further sessions. Yeah. So Karthik, let's start. So in this session, we actually want to design Facebook Live video platform. It's like I want to design a system where people can click on the live option and they can record any video they want, and the sharing should be real time.
Okay. Let me start with the function requirements first then.
Okay.
So first thing is basically from a user's perspective, I should be able to start a stream. I should be basically able to record my video and basically broadcast it to my audience. So that is what is basically live streaming. So I'll just say then the audience, which is also a user basically. So from other users perspective, user should be able to view the live stream.
Yeah.
So that is obviously the most basic functionality to but the thing is YouTube live stream as well as Facebook live stream, they also have an option for uh, likes as well as comments. So do we also want to discuss that?
I mean, those are just good to have. But our major intention here is to design the broadcasting system. Yeah. So yeah, we can have likes and comments, but I would say they're just good to have.
Okay. So okay, so yeah, that's basically what function requirement is. And let's talk about non-functional. So non-functional requirements are basically, the requirements from systems perspective. So basically, I mean, what do we, what are our expectations from the system? So here the things like, the system should be able to do this. The system should be able to, support this much, I would say scale, those kind of things come. So first thing is basically, let's talk about how much scale are we targeting. So the scale would be, so I've seen in case of Facebook, the number of users can go up to millions, I think. So I would say
I
1
think I
million.
think let's do one thing. I mean, let's assume that it's a very high skill system. I mean,
Mhm.
hundreds of millions of users can be there, right? So you don't need to do any scale calculation here. So let's assume that we have 100 million users here. So the scale is going to be pretty high. Yeah.
100 million users. Okay.
Yeah. So let's say 100
And I
million.
think,
Yeah.
yeah, so I'll assume that, we'll have probably, let's say we can take 10 million live streams per day.
Yeah.
Is that a fair assumption?
Yeah. I mean, let's
Okay.
focus on assuming that it's a very high skill system. So 10 million is a good enough number. Yeah.
Okay. So I mean, the scale, this is basically the basic scale which we are thinking. The one major thing is what should be the end-to-end latency. So for example, let's say when I'm on a video call, so that is also like a live stream only, but the latency expectation is actually uh, I mean, it's base. I would say the latency expectation is much, strict here than the case of live stream. So I
So
think 1 minute of
yeah,
latency would be fair to assume, right? 1 minute of end-to-end
yeah,
latency.
I mean, usually this kind of live stream system, whether they are sports live streaming or any kind of live streaming, they are essentially near real time, right?
Mhm.
So the point is that if we miss some frames of the live stream, also it should be fine, right? And for some reason, so something got stuck. So from that point on, you don't need to start. It can start from, at, as much as the latest frame possible, right? So latency was, I would say, maybe 5 seconds latency. So I
Five
want we
seconds, I think, would still be too strict in case of live stream. So in case of
okay. What do you think?
let's
What do you think?
so
Yeah.
in case of Hotstar, I've seen they broadcast with I think a latency of 5 minutes. I would say 5 minutes gap. But I think 1 minute would be a fair assumption. So 5 seconds, I
Okay.
think, would be difficult to achieve if we have
Okay.
a very high scale system. So let's go with 1 minute of
Okay.
delay.
Mm.
And this is from host to audience. And so of course, from so we will have all kind of users. The users will have all kind of devices, and they will also have all kind of network bandwidths, which means we should support our live stream for all kind of formats, and similarly, or all kind of network bandwidths.
Mhm.
So uh, I would just say multiple formats and network bandwidths should be taken care of. Then there is something called adaptive. Uh, what is it called? Adaptive.
So just one thing here. When you say network
What?
bandwidths, are we going to take care of it by having different resolution of the videos?
Yeah. That's what I meant actually. So network bandwidth is not the right keyword, I would say. So different resolutions.
Okay.
So also what happens is that let's say my network is very good right now, but maybe after 1 hour the network might not stay that good. So
Mhm.
what can happen is maybe I would want to switch to a lower resolution when my bandwidth is not so good. So that kind of case should also be supported if we want to have the experience
Yeah,
smooth.
there's just like choosing a resolution in the settings, right?
Yeah,
The infrastructure should be able to support multiple resolutions so that any resolution can be supported. We were just talking about a customization here, right? So that
yeah.
doesn't necessarily change the backend functionality. It's just something in the front end side. Yeah,
Yeah, that's true.
yeah. I
So,
think we can skip that part. Yeah, because that anyway you're going to support.
because our system should be available,
Mm.
we will talk about what kind of faults can occur in our system and how are we going to handle with them. Or I think better keyword would be failure handling here. Okay. Uh, what else? Can you think of something else which we have missed in the non-function requirements? We have talked about scale. We have talked about the latency.
Yeah, I think here the main important thing is like your system should be definitely available, and at the same
Mhm.
time, even some frames are getting missed, right? So it should be fine. So essentially, yeah, I mean, essentially we should be able to have lesser latency, but we should be able to have the latest data as much as possible. I think that's the main point here, right?
Yeah.
So I mean, if the network protocol that you are going to use is inconsistent, so that inconsistency should be okay, is what I'm saying, right? So yeah, yeah.
So I think we have got the functional requirements as well as non-functional requirements. So now we can basically talk about what are the APIs that will be involved in our system. So we'll basically, so before talking about the APIs, let me just walk through how will the system look like. So user will be basically we have a user uh, who is a host. So user comes to our platform. User basically starts the live stream, and then user starts the live stream, and then live stream is started. After that, user is continuously uploading their video. I mean, the host is continuously uploading their video, and from the audience end, the user is continuously kind of downloading the video. So the main API here is basically creating the stream. So I'll just use the REST model here, and so we'll be making a post call to /streams API to basically create a stream. So this API will basically start our stream, and it will have other parameters in the body. For example, user ID and maybe
So just
uh,
one thing here. So isn't it little bit uh, non-intuitive here to actually discuss the APIs here? Because once you have the whole idea of the system, how the
Mhm.
whole system actually works, and then we can actually come back to this API and design it. That what chunk of data to upload, how the APIs will look like, etc. Because once we discuss APIs here, uh, right, without having the high level design ready for this particular problem I'm saying, it gets a little bit non-intuitive actually to understand how this API is going to work, because this is not a normal API, right? This is a bunch of binary data that you're actually going to upload. So
Mhm.
maybe it's up to you, but we can probably discuss these APIs once our HLD is ready.
Okay.
What do you think?
Yeah, that makes sense actually, because I mean the system is actually like that only. So we will be
Yeah.
figuring out a lot of things. I mean, on the way. So it makes sense to basically complete all the APIs later. So let's
Okay.
talk about the hyper design. Uh, I have a library. Yes. So this is a, say, host, and so what I mean, like I said earlier, so I mean the host will come to the website. Host basically click some button, start live stream. The request will go to the server, and the basic setup, I mean whatever is basically to be done, that will be done, and the live stream will be started.
Mm.
So basically what we need is there will be first call that goes to the server, and that call is basically uh, that call basically creates the stream in the backend. So maybe let's call it stream frontend server.
So what is the call going to do? Can you repeat?
Just- So host basically makes a call to I mean stream frontend server, and this will basically start our stream. So
Okay, so this call is to just let the stream front end know that hey, I'm going to start a stream. So something like that. I mean, uh, is it like an intimation to the stream server? Then we also need to know what does the stream server actually say, right, to this host. I mean that yes, you can start. Then what happens?
So let me think for a moment. So user basically it's a go to stream front end, and then what happens? So
I think we should think. I think since it's more of like a discussion between us, right? So um, I think the host should be able to tell some server that hey, I want to upload a video to you, upload a media to you, right? Let's say video media or something like this to you. And then the stream server can ask it back that okay, fine, you are ready to go, but start from this this length, or start from this offset and upload till this offset, something like that. You get my point, right? So the
yeah,
API that the host is going to call of the stream server, the server should say it back that okay, fine, you starting offset is let's say 0 and ending offset is 10,000. So these 0 to 10,000 bytes you can upload together, right? And after the 0 to 10,000 bytes is gone, right? Uh, Either the host asks again the stream server, or the stream server asks the host or tells the host that you next offset is this to this, something like that, right? But I mean, we have to know that when is the end of the video, right? uh, so I think it should be stateful design, right? It's a very kind of stateful kind of thing, don't you think so?
yeah. So what will happen is host. I mean, once this stream has started, I think host should make another. So the first call would be an HTTP call when the host is actually starting the live stream. After that, host has to make a persistent connection with the stream front end or any other service through which basically host should be able to continuously send all the video frames to the backend. So yeah, we would need a sort of persistent connection
so i
here.
think so I think even before you do that, right, I mean, whether it's a persistent connection or not persistent connection, or I mean discrete connections, let's say that that's a secondary thing. The point is that the stream server should know that what is the actual length of the video that the host has, right? So I think the host can ask the stream server that hey, I have a video of length, let's say 200 MB in bytes, basically 200 MB in bytes, whatever bytes to upload. Now you give
No,
me.
so remember we are working on a live streaming system, so user doesn't
Mm,
know how much would be the size.
it depends on the client actually,
User
how the
only
client
knows
processes.
user only knows what is their current network bandwidth, so how much they would be able to upload maybe per second or per minute, and what is their current format, and
Yeah.
yeah, what else, and maybe some other meta information, for example user ID or other kind of things.
Yeah, so essentially right now there is no end, only the end happens
Yeah,
when the live
it's an
stream ends.
infinite,
Yeah.
yeah.
So basically when the video ends, the host should be able to tell the stream server that the video is ended now. So you now compile it or
Yes.
do whatever processing you want to do.
Yeah.
But also
uh
one thing is that as the host uploads the stream, right? Uh, these are live videos, right? So
mhm.
they should be able to go, they should be able to be viewed to the users almost instantly. So when you say
Yes.
latency, when
Mhm.
you say latency, maybe you need to be a clear bit here. You need to be a little bit clear bit here. What do you mean by latency? Is it like 1 minute latency? Is it like you received some frame 1 minute back, and throughout this 1 minute you processed it, and after 1 minute you are just broadcasting it, something like that? Do you mean by latency?
I think latency is not really the correct word to use here. I would
Mm,
basically call it delay. So delay between the actual broadcast and the time when you are actually seeing the video.
mm.
So delay
So
would
that
be the
one
correct
minute delay, if the delay is
1 minute
one minute,
delay.
would you like to take
Yeah.
would you like to take maximum 1 minute to process the frames or process the uploaded portion of the video, something like that? You mean?
Yeah. So processing and all
Okay.
everything should be basically done in 1 minute. So that after 1 minute, that that particular video segment or frame is basically ready for the user to
Mm.
view.
Okay.
Yeah. So yeah, so now let's basically store this uh, stream information somewhere. So let's say this is my stream database. I mean, let me call it stream database where we are storing the stream information. So this will have things like who is the host, those kind of things. So maybe we'll basically refine it later, but let's just talk about high level
Yeah.
things. Uh, so I mean, earlier, like we said, so we have a stream front end that will basically that is just going to initialize the stream, probably going to store some data in the stream database. And then what should happen is the host should have a persistent connection with the backend server, so that it should be continuously able to send all the packets to the server, and then server should be able to somehow broadcast them to the users, to the audience. For that, what we will use is so we will have a persistent connection here. So now there can be, how do we make a persistent connection? So for simple text based things, we usually use WebSockets to make a persistent connection. But we will not be, I mean, a WebSocket is not the ideal technology basically for making persistent connection when you are going to send the audio or video files over the network. So a better basically technology is RTMP, which is basically, I mean, the full form is real time media protocol. So real time media protocol is why is it?
Yeah, why is it? You can change the color, I think. Yeah.
Okay, nice.
So can I explain in 2-3 lines what RTMP does or how it works?
So RTMP, like WebSocket, RTMP is a protocol to make a persistent connection with the server.
Mhm.
So once the persistent connection is made, through this persistent connection, the user would be sending their video frames or segments continuously over this connection to the server. Then server can do whatever it wants to do with them. So it's very much like WebSockets, but this protocol is especially made for audio and video files, or
Okay.
audio or video data. So
Okay.
let me call it maybe uh, I think it's fair to just call it RTMP server. So which means now user has the persistent connection with the RTMP server. So now RTMP server has received the file, which is a video, or I mean, it will also include audio, of course. So what should we do with it? First thing is we should definitely store it somewhere so that whenever needed, we can uh, retrieve it and do whatever we want to do with it. So
So, so I have one question here. Why do you have
yeah.
separate stream front-end server and RTMP server?
So this is
I mean,
actually HTTP server.
mhm.
So and this one is basically RTMP server. So we can put both of the functionalities in the same server, but the thing is, since RTMP is a different protocol, so we might need a at least a different kind of server than the HTTP server. For example,
I mean, they're just a software, right? The servers are just a
the
software, right?
software,
So,
yes, yeah.
I mean, one thing
So
probably that makes a different sense is that since you need to upload data for some time to these RTMP servers, so
mhm.
it's better to have a dedicated RTMP server, maybe dedicated per region or dedicated by per cluster, something like that,
Yeah, yeah.
right? But essentially, but if you have low scale, both of them can be combined in the same server, right?
Yeah, yeah. I mean, we can just, run both of the servers on different port. One port for the HTTP server and one port for the RTMP server, and this can do our job. But yeah, if yeah, yeah, that can be done even with different languages. Yes. So
Okay, so like WebSocket is a persistent both-way connection, RTMP is also persistent connection,
yeah.
but only for objects you are saying.
Sorry.
Only for objects, only for video or audio or
Yeah,
those kind of
video and
video
audio
objects.
files. Yeah,
Okay.
yeah.
Okay. Maybe I need to read up a little bit on RTMP. So yeah. Yeah. You can continue. Okay.
So first thing basically is whatever is the video or audio file that we have received, we need to store it somewhere. So let's say, this has to be a blob store. So we can store it. Let's say we can basically use S3 here
Mhm.
because S3 is cheap and it's very simple. So we can just whatever file we have received, we will just store in the S3. And now the thing is, the processing also has to start for that particular file. So that particular video file should be converted to different formats and different resolutions. And
True.
if now there is one more thing. So the host, if the host is, let's say, we can define this at the host level that send a video for every second. So or that is one way of basically doing it. So we can ask the host to keep sending your 1 second video only. So the host will be sending their 1 second video to the RTMP server, and these 1 second videos we would be storing in the S3, and it's these 1 second videos only which will be basically broadcast to the users. The other method is basically we keep it flexible on the host end. So rather than forcing the host to send only 1 second video, the host can send, let's say, at once. Sometimes it can send maybe 5 second video, or sometimes it can send maybe 100 second videos, whatever is basically available to the host. So it will be good for the host if we keep it flexible, but it will be a lot of overhead on our system. So
Yeah.
the overhead would be basically we'll have to split these videos into segments. So let's say if we have a 10-second video, then we'll have to basically split it into 10 segments, 10 video segments, and then those 10 video segments should be processed.
I
So
think
for
I think the logic I think the logic will be simpler if you just ask if you can just configure in the host that 1 second is too less anyway. Let's say 5 seconds for now. That store 5 seconds of video and send it to a TMP server. So in that way, all the frames will be not frames actually. All the segments or chunks will be 5 seconds, 5 seconds, right? Maybe except the last chunk, right? So in that way, we'll have a consistent, uh, files of consistent size in S3 server or files of, sorry, in DB, if we use any object storage, right, or DB, right? Similar kind of record we'll have, basically similar size of record we'll have.
yeah,
So
it won't
or
introduce any extra edge
so
cases or
basically, yeah,
unexpected edge cases.
I think once you start processing these chunks, your processor will have predictable performance because we know
Yeah,
how much chunks we are actually processing.
yeah, yeah.
Right. So yeah, I think we can make it, yeah, constant size configurable at the host instead of just giving it the flexibility.
Yeah. So let me write it maybe 1 second chunks.
Mm.
Okay. Now we have stored these chunks in the S3 server. So of course they should now be basically broadcasted to the user. So how would the broadcasting look like? So obviously we should have something. So RTMP server. So essentially what the steps involved would be. Uh, so we should first download the file from S3. Then we should uh, convert it to convert the file to different formats. Let's say AVI/MP4, those kind of things. And then we also need to convert to different resolutions.
So one question
After
here.
that, it should be
So
broadcasted. Yeah.
yeah. So one question here. Once you upload it from RTMP server to S3 server, and I can
Mhm.
download it, isn't it two hops, two extra different hops? I mean, eventually, definitely you need some object storage to store it. I agree with that. But uploading and then downloading back just for the sake of processing, don't you think so? It's an extra hop.
That is true. That will be an extra hop. So
And
we
also,
can
if you
maybe
end up
optimize
if
it.
you end
Yeah.
up using if you end up using real S3 and S3 goes for a toss, then you are gone basically. I mean that any system can go for toss. I'm just saying this is more of like an external dependency here, right?
Yeah. Yeah. So let me basically take a note of this. I mean, solving this problem will not be that easy, honestly. So that's why let's take a note of this and we can discuss it, in the later part of the video. So,
Yeah, just write it
so
down here. Yeah.
yeah, yeah. So let me just note it here. In the total section. How do and dependency on S3. Okay. So the file has been received in our system. We need to start the processing now. So let's start the processing here. So of course, RTMP server, I mean, so RTMP, I think RTMP is also a request response system. So I mean, in any way, basically, RTMP server has to send the response to the host that I have received the chunks, and whatever is the processing that should be that should be happening asynchronously. So we need to basically send a sort of message from the RTMP server to the other processing server that we have files ready to be picked, and then those files can be picked for the processing. So let me.
So just one more point comes to my mind here. Let's say that while
Yeah.
uploading a chunk, right? For some reason the TMP server could not receive the chunk or it is lost. So how will the host know that it is lost?
If the RTMP server if the RTMP server was not able to process the
Let's
file
say
or
receive the chunk. Let's say receive the chunk, not processing, receive the chunk in the first place,
okay.
right? Is there any way that the host will get to know that the chunk is lost?
So I think so as far as I know, RTMP server is also, mm, I think it's also request to response model. So if it's a request response model, then once it has successfully stored the file in the S3, then only it will say that I mean then only it will basically say the success response to the user. So if it was not able to store the file in the S3 or something else happened, then it will basically throw an error to the host, and then host will maybe just skip that video or maybe just retry again. So I'm honestly not so clear on this. I mean, if RTMP is a request response model or request response server or not, or a request response protocol or not. So if it's like UDP, then we will just not know if one frame was lost. If it's like TCP, then I mean we can just send the response to the host that this file could not be uploaded, and then host can retry. I think we are okay in both of the cases since it's a live stream system, and we had basically said in the beginning itself that
Yeah.
it's okay to lose few frames.
Yeah. I mean, my point is that okay, it's fine. I mean, definitely in live stream you might end up losing something, but does a TMB does it have any way to actually let the user, I mean, ACK back, acknowledge back that hey, I got it, something like that, right? So maybe we can look it up later on. So just a point,
Yeah,
maybe you can take a note. Yeah.
yeah. This will basically come under failures. So video frame to basically RTMP, or let me just call it failure in. Okay. So what was the other failure that we were talking about? What if something fails at
Yeah,
in the
yeah,
RTMP servers?
yeah. I mean,
Failure.
if RTMP server was unable to receive some chunk from the host, is there any way that the host will get to know that? Yeah.
Yeah.
So we can take a look at it later, but it's a failure scenario to consider. Yeah.
What's happening? Okay. Something weird is happening. I'm not able to edit this. Okay. So basically, RTMP server will, kind of send a signal to the processing server that you should now start the processing. So how would it, send the signal? So of course, there can be one way is to, I mean, when the request had come to RDMP server will basically, opens a separate thread, and in that thread, basically it sends a call to the processing server, and processing server basically kind of receives the signal and starts something. So that is one way, but that's not really an intuitive way of doing it, and also not very fault tolerant. So of course, the most more popular and better way is basically using a queue in between. So we can use a queue in between here. So RTMP server will basically send an event to the message queue, and that event will be listened by the processing server. Processing server listens to that event, and now processing server basically starts the processing. So processing essentially has these three things. It first downloads the file from the S3, and then it converts the file to the different formats, and then it also basically
So when you
convert
say
those files to different
so when,
resolutions. Yeah.
yeah, when you say RTMP server is sending a message to message queue, what is the content of this message?
So it will essentially be an event, and it will have things like it should have stream ID, and it should have the uh, basically, I mean, it should have some information to know that from this location you can download the chunks. So should have some chunk ID, or we can send some chunk URL. Uh,
So
but
there should be some common ID coming from the host, right? Saying that this chunk belongs to this video, something like that, right?
yeah, stream ID. So I'm calling it a stream ID.
Okay, so that stream ID is generated by the host basically, right?
Yeah.
So it can
I
send
mean,
it.
stream ID was actually generated by stream frontend. So let me
Okay,
just try it here. So it returns stream ID here.
okay,
So then that stream ID will be using throughout our system. So
okay. So
uh,
whatever stream ID was written by the stream server, the host will relay the stream ID with every chunk uh, information to the RTMP server.
yeah.
And
So on the basic level, it should have at least two things: stream ID and maybe the chunk number or chunk ID. So let me just call it chunk ID would be we can call it chunk ID, but we can basically change it later. So it might just be a number, or it might be a UID. It could be anything. But for now, let's just say that it's a chunk ID. So chunk ID is unique to this unique for a particular stream, but not globally unique. So stream ID would be unique.
True.
On the basic level, it should have at least two things: stream ID and chunk ID. And processing server, upon looking, upon getting the chunk ID, it should be able to download the chunk from the S3 server. Of course, for that, what we would need is we should somehow store this information that this chunk ID, this chunk is basically this. This chunk ID's file is stored on this particular location or this particular URL. So for that, we would need some
No,
database.
I got confused. Can you say it again?
So basically, we have stream ID here, we have chunk ID here, but we don't have the URL from where we should be downloading the chunk, right? So for that, we can either pass the URL in the message, or what we can do is basically we can store the all the chunk information on in some basically database. So
Got it. So the RTMP server will basically store in a table that this is the chunk ID, this is the stream ID, and this is the S3 server URL.
yeah.
So upon receiving the stream ID and chunk ID, you are saying that the processing server will get the S3 URL from the table and fetch the object from the S3.
Mhm. Yeah.
Okay.
So now, in
Yeah.
reality, processing step is actually a huge step, and it's basically the most complex step. All of the operations which this step is doing, all of them are heavy. So first thing is basically it has to download the file from S3. It's downloading. Downloading basically means that it's downloading from a remote location, and it will be basically stored in at least in either some temporary storage or in memory. Then after it's basically stored to a temp location or memory, then after that basically it will be the second step is to convert this file to different formats, AVI, MP, or there could be other formats, and uh, then those formats should again be converted to different resolutions. So all these are heavy steps, and ideally there will be multiple steps involved here. So by step I mean multiples.
It will
There
be
will be
kind of
kind of
a
sequence of servers. Yeah,
it will be kind of a pipeline is what I'm thinking. The
pipeline. Yes. Pipeline is the
processing
correct
part
word.
that you are saying. So maybe
Yeah,
the
yeah.
first part of the pipeline will try to see that, okay, fine, what is the noise in this video? Can you reduce the noise? Then it reduces the noise in some way. And maybe the second
Mhm.
step then see, okay, fine, what are the different resolutions that it needs to convert, right? And in the maybe in the third step or something, it may see, okay, fine, how is the audio and audio quality essentially, right? Can we improve the audio? Can we do something else? Something like that,
Yeah, yeah,
right?
yeah.
I don't know, meanwhile, in between, whether there will be some level of encoding, encoding the video audio information in some way, or
Yeah,
some other level of optimization would be there or not. Those might be another points.
yeah, yeah. So basically, for the sake of this discussion, I think we can avoid that part, because yeah, so there also there will be multiple things like there will be queues and steps involved. So yeah, that's a we can
Yeah,
skip
I
that
think
part.
we can
Mhm.
mark it as like a pipeline uh, with multiple steps, basically, kind of a workflow pipeline with multiple steps, right?
Yeah. So let me just
Yeah,
call it processing pipeline.
yeah.
And this processing pipeline will now it will basically so the output of these steps is for one particular chunk will be you know converted into, let's say, at least 8 9 files. So let's say even if we just have two formats, AVI and MP4, and then those two formats will again be converted to at least, let's say, 4 resolutions. So we have 8 different files. So all these 8 different files for just for that segment should be stored somewhere. So again, what we can do is basically we can store all of them in an, I mean, the actual files we can store in the S3 server, but we also need some metadata. So by metadata, I mean that, this particular chunk of this particular format is basically stored at this particular location. So that information has to be there in some database. So let me database here, and let's maybe just call it a video chunk DB. Yeah, we can discuss about the schema of this, all the databases later, but let's just cover the high level for now.
There is also one more. There are few things going on here. First of all, so
Uh-huh.
starting from the last, when you are saving all these things in a chunk DB, there should be
Mhm.
some way of ordering the chunks also. Let's say there might be
Yeah.
parallel processing going on, and one after another chunk came, and out of order processing happened in some way or other. Let's say, right, due to system issues or whatnot, some way or other out of order processing happened, right? But there should be some way so that we can retrieve the chunks at least in time order or in sequential order, and can relate back to all the connected audience, first of all, right? That's one thing. And second is like, we are introducing S3 here, which is an external dependency or per se any other object storage, right? I just want to discuss one alternative method. The message queue that you are using, can you directly put the object in the message queue? So the S3 server can contain the object definitely as a permanent storage, but
Mhm.
from our TMP server to the message queue, can we put the object itself in some way, right? And the processing pipeline can consume the message directly from the message queue and process it.
So as far as I know, the maximum size for a particular message in Kafka can go up to 1 MB or 2 MB, I think. I think it's 2 MB. So
I mean,
uh,
why are you designing very specific to Kafka? It can be something else also going forward, right? But even 1 MB is good enough size for, let's say, 5-second video or maybe 2-second chunks. I don't know, I'm just assuming. For a 2-second video chunk, maybe 1 MB is a good size, right?
I mean, we can test between, I mean, both of these approaches. But I feel, message queues are basically not made for, storing these I mean, this kind of heavy data.
Mm,
So I mean, so the thing is basically the throughput of Kafka as well as latency is basically kind of decided by uh, the speed at which it's able to write on the disk. So if you are basically writing huge messages on the disk, then what can happen is the overall latency as well as, I mean, throughput in terms of data might probably not suffer, but latency will definitely suffer. So what can happen is when we are storing big messages, let's say of 2 MB in the Kafka, then for one particular message, the overall latency might suffer. So it's possible that,
mm.
instead of getting a, let's say 10-15 milliseconds of latency, we are probably getting maybe 1 second of latency. So that is one possibility which can happen if we start
It's a
storing
good
big
point.
messages.
It's a good point, by the way. I mean, I just wanted to explore, is there any way so that this binary data can be encoded, right? Encoded in some format or compressed in some format so that you can put it to the message queue, right? And then process it. Definitely, there are trade-offs, as you said, right? And if you compress, decompress also, that might also take some time. But I believe since it happens in memory, so depending on the algorithms that you choose, the compression decompression time still might be lesser than uploading and downloading to S3 server or downloading to S3 server or something like that,
Yeah,
right?
that's true.
Yeah. Okay. Anyway, I mean, that could be something that might need some exploration. But yeah, for now, let's go ahead with this approach and see, yeah, what happens next.
So, I mean, as you mentioned earlier, the ordering of the chunks. So that is also one thing that we will have to talk about. So let me basically put it in to do right now, but we will actually see later that ordering will be basically this will basically cover, this will be covered in in the broadcasting part. So let me just still take a note of it. So ordering of chunks.
I think it would be easy to solve if you the chunk ID that you're talking about, right? If you can
Yeah,
generate the chunk ID as a Snowflake ID, it should be easily orderable. So Snowflake ID is generated in such a way it's a numeric ID, right?
so
It will be
you can
always
actually just
increasing.
give them numbers to the chunks. So you can just, when
Yeah.
your stream is starting, you can just give number one to the first chunk, and then, after subsequently, you can just keep incrementing that number as well. And
Yeah, that
this,
also, yeah, go ahead.
yeah, so that is also actually, it's it's not something that, is just theoretically possible. It's actually done in reality as well. So yeah, I'll talk about that in yeah, very soon actually in the manifest file.
Yeah, I think anyway, chunks are generated by the host for a particular video, right? So in the context of that
Mhm.
particular video, the host can anyway incrementally give it numeric ID or numeric
Yeah, there can be
numbers.
several ways actually. We can just punch a timestamp on those chunks, or natural number, or could be anything.
Yeah, it is not like the chunks are coming in, thousands every second
Yeah.
uh, for a particular video, right? It's just a single chunk.
Yeah, yeah. The
Right.
source is single. Basically, we only have
Yeah.
one single source. So the ordering problem, it's not difficult to solve there.
Yeah. So there is also one thing here now, which brings me to again to the pipeline thing. Let's say that there are three stages to this pipeline. Okay. And in the stage one, let's say a noise reduction happens. In the stage two, let's say audio enhancement happens. In the stage three, let's say video encoding and some kind of manipulation happens, right?
Mhm.
So how are the stages going to communicate to each other? Given that you also spoke about the disadvantages of using something like Kafka to store binary data, right? So how will the processing pipeline would communicate one to another, or is it going to be full in memory?
Uh, so in memory, I don't think it should be. In memory basically. So what we will have is we should have some sort of temporary blob storage within our data center, or within basically our system, I would say, which is basically from where it's. Yeah, the files are faster to download. So we will be basically storing those files to that location, and at each step we download that file, and then we basically convert we process it file, and then we generate more files. Then we basically store those files there, or maybe to the S3. So we can actually just altogether skip this temporary in-house storage, and we can just directly use S3. But the only thing is basically the overall latency will suffer. So
I mean, why
yeah.
this processing is important because here the host is not going to retry. I mean, once the host uploads the video to RTMP server and RTMP server has acknowledged back, let's say that for now it acknowledges back to the host. The host's
Mm.
responsibility is done for that particular chunk, right? And if the system is not efficient enough to manage the chunks or to do the processing, or if we keep on losing multiple chunks one after another, the video is not coming to be good, right? So that's why there should be some level of storage. Either it's internal storage or some kind of, let's say, MKHD kind of storage, right, which can storage object in memory, if I'm not wrong, right? Something has to
Yeah,
be there to
in
make it
memory
more
we
reliable.
definitely cannot. Yeah, we cannot keep things in memory. One the reason basically is this data can be lost, and the other reason is basically or overall I would say processing will suffer. So you cannot just so we always have limited RAM. So the size of RAM is limited, and our processing will basically suffer if we just keep things in memory only. So at the time of
Yeah, no, when
processing,
I said
probably.
when I said
Yeah.
in-memory, I mean specific dedicated in-memory server to hold them for the time of processing. But the issue there is that if, let's say, the cache itself is gone, the in-memory server itself is gone, right? Then there is no way to process it back because the host probably won't upload it back, and we are not going to make it complex design that we are again going to ask the host that, hey, upload this chunk, something like that. It's not going to work, right? So it has to be simple. So if the cache is gone, then probably the whole processing for that particular chunk is gone, right? So
Yeah.
maybe something like, as you said, as you mentioned, correctly mentioned, maybe something like temporary blob store, local blob store, or maybe some DB which is optimized for binary data storage can be used. I'm thinking as an intermediate storage, right?
Yeah. Yeah. Something in-house basically.
Yeah.
So yeah, I mean, if the time remains, basically we can basically come to this step. There are actually a lot of things to talk about here. So basically, failure is also one interesting aspect to talk about in this pipeline. So what happens if step fails? Then what do you do?
Yeah, we can actually talk
So
about it. Yeah, maybe you can take some time to talk about it. Yeah.
you mean right now?
Yeah.
So for that, actually, we will let me just maybe talk about it very high level. So let's say we have these three stages. The first stage is let me just call it downloader stage. So down stage is nothing. I mean, it's basically a bunch of servers. So let me just probably better to call it them servers. So these are our downloading servers. So they download the file from the S3 and then they store it in let's our in-house storage. So the file has been stored here now. So now basically the request should go to the next step. So next step is
Mm.
basically convert the file to different formats. So we can maybe call it um,
Maybe call it enhancement, right? Audio enhancement, and then next step you can have the conversion step, something like
yeah,
that. It's up to you. Yeah, just for example.
yeah. Let me just call it formatter server. So this will basically generate all the formats, new formats. So of course, what we will have is so downloader server should have a way of communicating to the formatter server that I have finished the downloading. Now you can start. So for that, basically what we can do is we can have a queue in between here, and that queue will from so some event, and then that some event will be basically listened to by formatter server. So formatter server basically listens to this queue and then starts converting to formats. Basically generating the new formats.
Hmm.
So here also, ideally, what we should have is we will probably have a so on a very high level, let's say we are finished down. Converting all the formats. So let's say we have three formats: AVI, MP4, and maybe some other format. All three formats should be generated before we can basically ask the next step to start. Which means we need to basically wait for all these steps to complete.
Mm.
So one way is basically if we want to do this in within the formatter server. So formatter server, then let's say it's basically one process. That one process listen to the message that this process would have probably started three parallel threads. In these
Okay.
three parallel threads, we are basically converting to different formats. Once
Mm.
all these threads are complete, then it goes and I would say sends a message to the next step that I'm done. But that is one way. But here again we are, the same server is basically doing three things. And there is also one more problem here is, let's say it's easy to generate AVI format and MP4 format, but let's say we have a new format which is actually not so easy to generate. So what will happen is, these two threads which which have already finished their task, they will now be waiting for the third format to complete. So then, I mean, basically we are wasting the time of two threads. So this approach, so this is
So,
basically one problem with this approach. If we
so
are, just
one
yeah.
question here. Let's say before you move on to the next format, right?
Mhm.
Why do you want to generate all the format? What is the next step first question? And why is it
So the next
dependent on
step
all
is
the
basically,
formats?
yeah. So next step is, let's say we have four resolutions. So
Hmm.
144, 144, 320, and 480, and then
Yeah, yeah.
1000.
Hmm. Hmm.
So all these formats should also have four different resolutions. So if we have three formats, then and four resolutions, so in total we should have 12 files, right?
Yeah.
So first we convert to formats, and then we create their resolutions. So resolution is ideally kind of when you are going to the lower resolution, you are sort of just skipping some pixels, or maybe in audio sense, I don't know what would it be, but yeah, in image sense, it's basically skipping some pixels.
So, so just to simplify this a little bit here, right? Since it's an in-app live video, right?
Mhm.
So why do you need so many format? I mean, whether it's an Android app or whether it's a Mac or whether it's something else, right? Windows, let's say, right? When the live is happening, it's eventually the app which is interpreting the chunks and showing it to you. So why do you need even so many formats? Why not to just keep it to maybe one format or two format? And also resolution wise, often live videos are optimized not for HD. I don't know, whatever live video I have seen, they are all like very
Mhm.
average resolution, right? So maybe one more way to optimize is to that the resolution hardly let's limit it to 320 max, not more than that, right? This is not kind of Netflix or anything like that. You are allowed to download in some format, specific format, so you need to generate those formats. So can you skip
So
those formats
resolution,
and
I think we
resolution?
can maybe instead of four resolution, we can have three resolution. But I think a lot of people just watch the matches on their TV. So on TV, if we just show a video in 144 format, then it won't really be a good experience. So that's why I think we can reduce the number of formats. So we can maybe force the audience to just use one format for viewing. Is that possible?
Yeah, I'm saying that since it's an app, right? It's an app which is eventually interpreting. The platform doesn't matter, right? Whether it's a TV or whether it's a big computer screen or whether it's Mac or doesn't matter, right? So the format may be a single format. Will it work? First question, and maybe the resolution could be different. Yeah, maybe for a small mobile, whatever resolution works, right? For a Pro Max or for a tab, the same resolution won't work. It will break, right? So we might have different. I mean, sorry, different resolution we might have like 144 and maybe 480 and maybe 720, something like that. That makes sense. But I'm more concerned about actually the format here. Can a single format work?
So for uploading one single format, I don't think can work. So the thing is, if you have seen in Facebook, so if you basically let's say you take example of you're trying to start the live stream from your phone, so your phone browser. So at that time, when start the live stream, what will happen is it actually opens your camera. So and that camera can produce the output in a certain format only. So it cannot I mean, you basically need to respect the format there, I would say. So whatever format it basically produces, you just have to
I
take in
see.
and convert that to a new format. So I'm not sure how it works for, I mean, for the player part.
Yeah, see, all I'm
But
just saying is that there might be some five different formats coming from, let's say, five different type of devices. But when
yeah,
it goes to your processing pipeline, the output format is the same format. That's what I'm saying. I
yeah,
mean, you
but
can.
yeah, I'm honestly not sure about that. If we can, have one single format. I think YouTube only has one format. So, but
I
yeah,
mean, eventually
yeah,
you are just
that's
showing it in an
yeah,
app, right? So
yeah,
ideally, if you make it to one output format or converge it to one output format, then it will greatly reduce the complexity of the problem,
yeah, that is true.
right? And then you can have multiple resolution. I understand the point of resolution. Yeah, maybe we can have three, four different resolutions. That should be fine. Yeah.
Yeah, yeah,
I think let's simplify it. Let's create only one single format and then maybe apply multiple resolutions for the sake of this problem for now.
yeah.
So there
So
might be
format.
different input formats, but
Uh,
the output is single format. Let's say MP3 format. Yeah. Is
yeah.
MP3 audio? I don't
So,
know, man. It's MP4 something. Yeah.
yeah. So for any input parameter, it will basically convert to MP4 file, format.
Yeah.
So after that, we basically need to send this information to the next step, which is basically a, let's call it, resolution server.
A
So
resolution
then,
enhancer. Resolution
yeah.
enhancer. Some. Okay.
So now this server will basically, I mean, again, I basically skipped the messaging queue part here. So of course, the messaging queue
Hmm.
goes in between here again. Resolution enhancement server. This will also basically, I mean, its task is to convert the incoming file to many, let's say, four different resolutions. So it's a yeah, I mean, the one method which I talked about earlier, we can do it in that way, but that is not very efficient. So rather than doing that, what we can have is we can have multiple different servers here, each doing their, I mean, for different formats, or sorry, different resolutions. So let's say we have four different servers for four different resolutions. So these servers, they pick the file and then they convert the file to a, I mean, they basically generate an output file which is in a particular resolution. Then they, let's say, they store it in the in-house blob storage. So how does the resolution enhancement server get to know that all four steps have been are complete? Uh,
So is the design getting complex? I mean, let's say it's a resolution and enhancer server, right?
mhm.
Uh, I mean, eventually you can take the message from formatter server and you can give it to, let's say there are multiple instances of resolution server, right? So you can just give it to one of the resolution servers, just like load balancer. Is it possible? So basically, one lightweight proxy kind of server takes the message from formatter server, and then it gives this data, this message to any of the resolution enhancer available, right? And then once some what do you call it, data is there, result is there, it just simply uploads to DB or whatever the final location or the metadata is to go. So the back and forth won't be there, right? I mean, uh, you don't need any back and forth,
uh,
but we need to take care of in the meanwhile if something is lost, then what will you do? That's a different thing.
I mean, I'm thinking that, once all the format, I mean, once we have all the resolutions, then we basically go to the next step. Uh,
So by the way, uh,
mhm.
it's a very workflow kind of thing, right? So
Yeah,
I think when all of the steps are getting completed, they need to store some data to some metadata DB or some DB, right? So can you use the same video chunk DB, uh, you know, as the intermediate metadata storage, just to keep track of which chunks has already been processed or which chunk is under processing, etc., something like that, and at which stage, so that at any stage, if let's say the further processing breaks, right, we can restart the stages.
Yeah, we can do that. So yeah, I mean, the information here, I mean, the chunk information is basically which we were basically talking about the at the resolution stage. So that is very much similar to the video. I mean, whatever we were storing here. Uh, Actually, this video chunk DB was storing the output of this whole pipeline. So yeah, we will be using video chunk DB only anyway. Yeah,
Yeah, there might be different table, right? I
yeah,
mean,
there might be a different table. Yes.
yeah. So there are two things here. One
Essentially, I
is
think
there
we
are
can
two
use the
things.
same DB
There
technology.
are two
Yeah.
things we're talking about here. Using a table to store the interim metadata so that we can restart the stages if any stage fails. And the second is your approach of resolution enhancer server, right? So, uh, I mean, can we just simplify it, right? Can we just take data from the message queue and any of the resolution enhancer server can process it, put it to the DB, and then move to the next step or something like that.
Okay. Uh, you mean I mean you mean basically the output of this has been stored in the video chunk DB and we talk about the further things, right?
Yeah, I'm just saying that in the pipeline, whatever the, let's say, downloaded server, right? So it has downloaded, let's say it has downloaded some chunks. So in an intermediate table, it will store the chunk information as well as the current state of the chunk, right? That it is downloaded, right? And then it sends a message to the message queue and then formatter picks up. And then when formatter picks some particular chunk up, it it updates the record saying that let's say formatting something like that, right? And once the formatting is done, it can say that okay, fine, formatted, and then it puts a message to the resolution enhancer. And then when the resolution enhancer picks it up, it tells that okay, fine, resolution or enhancing progress, resolution enhancing in progress, something like that. And then maybe any of the resolution servers, just to scale it up, right? Any of the resolution servers can pick it up, and when any resolution server is done with the processing, it can add a new record that okay, fine, resolution done, or update the record that resolution and enhancing done, right? And it can send a message to the next step if there is any next step, right? Or act accordingly. So do you see that this approach works, or do you have anything in mind?
Yeah, I think that will work.
Okay.
So
So then
I'm
once the resolution enhancing is done, right? What is the next step? I mean, what do you do after that?
so I'm assuming that we this pipeline also generates an event that this particular for this particular chunk all the steps are complete and now this is basically ready for the broadcasting. So for broadcasting, actually, by broadcasting, what I mean is, we have a video, and let's say there are 1,000 watchers of the video. So the 1,000 watchers will be basically they'll basically kind of download this video and basically they'll see it on their device. Now, how do they basically get this video on their device? So one way is basically, once the processing pipeline is done with processing, it actually makes 1,000 copies and it basically, transmits all those 1,000 copies to these users. But of course, that will be, not so scalable. So essentially, what should be happening is it should somehow, it should somehow tell the users that the processing is done, or maybe not tell, but basically what should happen is basically these 1,000 users they should download the file from some central location. So uh,
So coming back to this point, right? I mean, once your resolution processing is done, right? You have multiple copies of the same video, let's say, right?
yeah,
With different resolutions, with the same format, let's say for now, and with different resolutions. So the question is, do you upload those resolutions to S3 server and update some table in the video chunk DB and then
Yeah.
transmit them to the user? So can you just talk about that flow?
Okay. So okay,
So
so
you have
let's
some
assume that
central table,
the
right?
chunk is,
Yeah.
uh,
You have some central
we
table,
are
right?
assuming
Which
that we are assuming that those chunks are in the in-house blob storage. So and they haven't gone to the S3 as of now,
okay.
right? That's what your assumption.
Even after resolution enhancement.
Yeah, yeah.
Okay.
They're still in the in-house blob storage,
Mhm.
and from there they should be basically uploaded to the S3 server,
Mhm.
and yeah, and basically some data would be stored in the database, video chunk database. That for this particular chunk, this is the URL in this particular
Okay.
format
Mhm. With this particular pixel, I mean, with this particular resolution, basically.
at this particular resolution. Yes.
Yeah.
So basically, the schema here would look something like this. So we have chunk ID, let's call it, which is a kind of primary key. So
Mm.
and we will have stream ID. Actually, I mean, we have earlier said that chunk ID is not globally unique. So of course, the chunk ID cannot be primary key here. So the primary key would be basically, it will be a sort of composite key, including
Yeah.
chunk ID as well as stream ID. Then it will
So
have
basically,
three.
stream ID, comma chunk ID. So stream ID is the first, and chunk ID is the second one. Yeah.
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 Then it will have S3 URL. So since we were saying that we will be using in-house blob storage, and of course there will be some way of accessing the in-house blob storage. So which means I am assuming that in-house blob storage also kind of have S3 URLs, and whenever you want to access something from the in-house blob storage, you actually call that API and you basically get the data. So let me just call it in-house blob IHB URL. So
You need resolution also and format also in this schema, right?
oh yes, yes, yes. I mean format. Yeah,
A
we can just keep it.
format type, and resolution type. Yeah, something like that. Format and resolution should be fine. Yeah, it is okay.
Yeah. And of course, there will be other information like created and also we can
Yeah, you can
skip
leave
that.
that. That's fine. So I have one more. I have one more question here. Let's say we are using S3 server and we are storing data from RTMP server to S3 server directly, right? So why don't you directly use the in-house S3 service there or in-house blob storage there instead of S3? Because that's a temporary chunk data, right? All that really matters is
Yeah, yeah, that makes
your final
sense.
result, right? Right.
Yeah, yeah, yeah. So if we have in-house blob storage, we actually don't need S3 because I mean so since we are actually saying that this is a temporary storage. So since it's a temporary storage, there should be some permanent storage. So in that sense, we should have one copy in the S3. But if it's a reliable database, I mean the reliable storage, then we don't need that. So it pretty much comes up to if it's a reliable storage or not. If it's
Yeah, I
reliable, then
mean,
we do story. Yeah.
yeah. I mean, let's say you want to browse the video even after the live streaming ended, right?
Mhm.
Then also you need these chunks, right?
Yeah.
So then maybe while you store it to S3, you can probably store it parallelly to in-house blob storage. And so the internal processing happens through the in-house blob storage, and only the output for future actually is stored on S3 server. That is the main assumption here,
Yeah. Yeah.
right?
We
So that
can
we,
say inputs and outputs, both of them are, in S3. And at all the intermediate stages, we are basically storing in the temporary storage. So by input,
Okay.
I mean that the first raw file which comes to our system, that also will store in the S3 just for the backup.
Okay.
Yeah. So do you want me to talk about something else here, or should we go ahead for the broadcasting part?
You can go to the broadcasting part for now.
Okay. So broadcasting is basically, I mean, this can be done in several ways. One is, we have users, they have got the stream ID, and what they do is basically at every few seconds or every few, yeah, I mean, it would be seconds only. So every few seconds, let's say 1 second or 5 seconds, they basically call our server and to check if there are new available segments, I mean, available or not. So that is one way. The other way could be using something like a sort of persistent connection. I mean, we sort of create a socket connection from user to the backend, and through this socket connection, the video chunk is basically sent to all these users. But of course, as we have seen earlier, that for the same particular purpose, we were actually using a different protocol, RTMP protocol, and we were not really using the WebSocket because WebSocket is not for the video and audio files. So I mean that so RTMP we could use, but if you look closely, even for RTMP, what you will essentially do is basically you will be creating 1,000 different copies. If we have 1,000 users, then we will be creating 1,000 copies for the same video file, and then you will be transferring those files to 1,000 different connections. So, I mean users, and then there is also an overhead of maintaining these connections in the RTMP server. So the servers become stateful now, and with the stateful server basically comes a lot of technical complexity. So I mean so that is one way, but that is really complex and really resource intensive way. The third approach, which is actually used by I think all of the live streaming systems, where people are okay with 1 minute, up to 1 minute, or maybe let's say 5 minutes of delay. So this approach actually, what it includes, it there is a sort of manifest file. So manifest file is sort of I mean, it's basically a file which contains some information that these are the segments. So manifest file can be of different types. So on the very basic level, it actually contains information like what is the base URL for all the video chunks. So there will be, it will have information that, what is the base URL. So let's say my base URL is slash stream ID slash stream ID is my base URL, which means that slash after, I mean, if I want to download the chunks, I'll have to append some information to slash stream, and then I'll hit it. Then I'll basically get, download the file. And then it has basically chunk information. So chunks are basically called segments here. So it will basically also say that if you want to generate the chunk URL, that then the segment URL will look something like this. It's basic sort of regex kind of URL. I'll probably give an example here. So the segment URL, I actually forgot the exact name of this URL, but yeah, it looks something like this. So, dollar slash segment underscore dollar dot mp4. So the dollar here means variable. So dollar basically means that something, anything, basically the dynamic part here. So you can create the actual segment URL like this. Let's say my base URL slash segment underscore. Let's say if I'm downloading the first segment, it would look like segment underscore one dot mp4. So this would be my segment URL, which the browser will hit to download this segment. So this manifest file actually contains all the information. So it also contains, let's say, for different bit rates, what will be the, so for different bit rates, I mean, what is the URL? So let's say if my bit rate is
So when
yeah,
you say segment, essentially, does a segment map 1:1 to a chunk?
yeah. So
The
segment
segment is
is
essentially
chunk only.
chunk only. But how
Yeah.
will the client know that give me segment one, segment two? I mean, uh, how do you come? This is the chunk information is in the backend side, right? So in
Yeah.
the client side, it has nothing. It doesn't know anything. So how does it know?
So basically what happens is you can the manifest files can be I mean they can be generated in any way. So one way is basically to number your segments basically, and give them natural numbers only. So you can start with 1 2 3, so you can basically give them natural numbers. And
Mhm.
so it will so I mean the file has some start segment or something, start segment number or something, and let's say it has one. So if the manifest is like that, then what will happen is now the player knows that all the segments are numbered in a natural way. So what it will do is it will just at its own speed, it will try to download those segments. So let's say it will download 1 2 3 4, 1 2 3 and 4 it downloads. Then after some time it will basically start downloading 1 5 6 7 8. So if it's not able to download, then it will be just wait. So it's actually not waiting for any event to happen that this particular segment is available now or not. I mean, so
Mhm.
it's basically just there is no such event that is basically coming from the backend. It's just waiting for a particular segment number to be available and just download it. So there will be no communication from the backend. It just downloads the manifest file, and using that manifest file, it starts downloading.
So
So
since it's a live video, does it need
yeah,
to keep on downloading the manifest file?
yeah. So what happens is basically if there is any change in the segment manifest file, then it will have to download it again. So,
But how
but
will it
in
know?
most cases, it doesn't have to download. So I
No,
mean,
I
I
mean,
mean, at the startup stream. So at the startup stream, it will download the file, and then after that, it knows that the segments are
how,
starting from this 1 2 3, and then it will just keep downloading. Yeah.
yeah, I mean, once it knows that fine, the segment starts from one, it can
Mhm.
automatically try to download. Sorry, it can automatically try to download the chunks. I understand that part, right? But the point is that it has to know somewhere, right? That I have to end, I have to stop, or the live video ended because the live video is constantly coming, right? It's not a complete video yet, right? So how will it
Uh,
know that the live video ends here?
and the part, I'm not sure. I think uh, I'll have to check maybe. I mean, I think what happens is basically it periodically polls and downloads this file. But for the meantime, I mean, it just follows what is written in the manifest file.
I think what I mean in this way, basically, what could be working is like the we need to keep on updating the manifest file, right?
Mhm.
And let the client download it, right? That hey, I mean 1 to 10. I mean start is 1, end is 10. Let's say something like that we have written in the manifest file. So after 10 is ended, right? The server can ask that hey, give me the next manifest file. So the host can ask to give me the next manifest file. So now the server gives, and maybe there will be some end marker, right? That's after 10 there is no segment, right? So the server
Yeah.
simply say that okay, fine, segment ends, something like that, which the player can easily understand, and then can end the video, right? I mean, for a static file, the video is already there. Let's say in
I
that
think.
case, your segment file
Mhm.
will be complete anyway altogether. But for live video, in this segmentation way, you won't have the full segment information yet. You need to keep on
One
downloading
more
maybe.
thing
That's
that,
one way.
yeah, one more thing that we can do is basically the last segment, we can actually put some meta information in the same segment, and once the player basically reads the last segment, it's able to know, and this was the last segment.
No, I
So
mean you don't have a way to know it's a lost segment, right? Because let's say you are going to do a live, some customer is or some user is going to do a live video for 1 hour, right? And you
uh-huh.
are pushing segments only 1 second or 5 second segments, right? So in the middle, you don't have any way to know that this which segment is going to be the last segment, right?
So if user basically, let's say if there is some button on the client side that basically says end live stream, then we can send this information that this was the last frame. If it's not like that, user just closes the browser and just goes away, then we can basically, there would be some sort of timeout.
Yeah, I mean when
Timeout.
the
Yeah.
when the host ends the live stream, right? You are anyway. I mean, if it's event driven, you are anyway. You can anyway push a manifest file to the client, right? Or if it is not, you already know how many chunks are there currently, right? So depending on that, you can calculate on the fly that whether this is the last segment or not.
So number of chunks we don't know, right? So the thing is, actually we know, uh, manifest file actually gives you the information what is the length of each segment. So length
Mhm.
of segment is actually given by the manifest file. It could be 1 second, from 1 second to, I don't know.
So there are few
Uh,
there are few there are few scenarios here. Let's say the host clicks the end live stream button.
yeah,
Then it's a clear
yeah.
cut way to know that the segment ends here, right? And then we can push some kind of we can push this update in some kind of manifest file saying that the segment ends here or some segment ends here or it's an end of the stream altogether, something like that, because
So
it's a clear cut event that you have,
even
right?
in that case, actually, so even in that case, user will have to then download the latest manifest file. That is the problem.
Yeah, yeah, yeah.
Until user downloads the manifest file, user has no way of knowing that the live stream has ended. So we need to basically send this information through the segments only, segments or chunk. So we can basically embed this information in the segment only, and the player will basically able to read the information from there, and then say that this was the last segment.
But can I embed it? I mean, not in segment, but the segment is getting pushed through RTMP, right? So is there any way to push some header in RTMP that okay, fine, these are the segment metadata
I
or
think
something like
that
that?
can be done actually. So videos always have header information in them. So which basically, I'll give you an example. So if you download any random video which has no information, you'll still be able to know, what is the size of, I mean, what is the size of this file and what is the resolution of this file. And you don't really, ideally, you should be able to, you should be basically reading the total number of bytes and then calculating, but you don't need to do that. You can just read from the uh, header. So I think that information is embedded in the videos anyway.
See,
But
see,
yeah, check.
there are two scenarios here. Once the host ends the live stream, so whatever last chunk is being uploaded by host, that header can contain the information that it is the last chunk for the stream. So that's a clear
Mhm.
cut case, right? So that is a good case. Now, whether you make a manifest file or you push some event to the clients to figure out that it's the end of stream, that's a different thing, right? But the point is that if the host is doing a live stream and suddenly he closes the app or she closes the app or suddenly battery dies, let's say, right? Then the header doesn't say that the live stream ends.
Yeah.
Then there has to be some way to figure out that the live stream actually ends. Maybe based on time, something like that.
So
But uh,
I think on the audience side, we can have a timeout that the player will basically keep calling the server for the next segments, but server is not giving any new segments. So it waits for some time. There is some sort of timeout, and then it basically says to the user that this live stream has ended. Could be maybe 10 second or 15 seconds, something like that. Now, how should the backend know? Should we store this information in the backend or not? That this stream was ended at this particular time. So if we want to do that, then we need to have some sort of timeout system in the backend. But I think that is not needed. So
that is
what
not
we can do,
needed. Yeah.
yeah. So whenever someone wants to see when was the video ended, then it can just look at this last segment which was published. So rather than having some sort of timeout system at the backend, which updates that it when the timeout happened, all the get requests can just look at the last segment, time of last segment.
Yeah. I mean, that makes sense. So, okay, just to clarify here for the audience, right? So, are we going to push manifest file, or is the client going to ask manifest file every sometime? Or the segment header themselves will actually tell that, okay, fine, this is the segment metadata from 1 to 10 right now. And after 10 is watched by the client, watched by the user, the client will automatically ask for, hey, give me 11, something like that. So, which approach you are taking finally?
Uh, I think so. I think we can go ahead with this approach. I mean, uh, when we basically publish the manifest file only once, and in the segment maybe we basically put this information, so that I feel is will be more reliable. Uh,
So, manifest file
because,
contains what? Your manifest file contains
so
the
manifest
starting
file
segment,
contains
or
only these things. I mean, it doesn't contain the last segment, or if the stream has ended or not. It just contains all these information, and player basically decides if the
so
stream has ended.
it doesn't need to say 1 to 8 or anything like that, right? It can just simply say that start segment is 1, and the client
Yeah,
can
yeah,
now
start segment.
numerically,
Yeah. Start
yeah.
segment is 1, and you need to keep adding basically 1 to this segment number to keep down download the next segments.
Yeah, so I think what can happen is like the manifest file can tell that hey, start segment is 1, and you can ask for maximum, let's say 10 segments,
Yeah,
something like that. Max segments or something like that has to be there. Max segments is equal
yeah,
to 10, let's say. And the client
yeah,
can then ask for, okay, fine, give me 1 to 10 segments in order. The backend is actually going to give it basically push, 1 to 10 segments,
yeah.
right? And then once the 10 segment completes, it can ask for, okay, fine, give me segments from 11 to 20, right? But how is it asking? Is it asking through some HTTP call? Or how is the client actually asking for the segments? There should be some HTTP call, is it, or something like that,
So
so that you can push the segments.
I mean, in reality, what happens is basically we have basically another protocol called Dash protocol. So Dash protocol, actually, in this protocol we do all these things. So it's a HTTP based protocol only. So I mean, when you're
I think
using this protocol, yeah,
too much of
yeah,
buzzwords here. That's what I'm saying. I mean, just to keep it simple,
yeah.
right? So maybe
But
you
yeah,
can, the
keeping it
client
simple,
can
it's
just,
HTTP only. Yeah,
yeah, the client can simply ask an HTTP call, hey, I'm done with 10 segments. Now give me segments from 11.
yeah,
And then it becomes easier, right? The server can say, that, hey, I don't have any, uh, segment. So the server can say that, okay, in the response that, hey, fine, I have segments I'm sending you. So receive it in the RTMP port, right? Or it can say that, hey, segment ends, I have nothing. Or the server can simply time out, something can happen,
yeah. So there is
right?
one more way to actually solve this problem, which I think would be better in our case. So what we can, rather than just saying that this is the start segment and you just need to keep adding 1 to the number of segments, what we can have is we can also just provide the list of
Okay.
segments in the manifest file. So let's say we give let's say 20 segments here, and all these segments have URL. So we give 20 segments here, and so the first time basically user starts the seeing the stream, this file is downloaded. These 20 segments will be downloaded, and when the player sees that I'm about to finish all the segment, then it makes a call to the server again and fetches the next manifest file. So, and then that next manifest file will have 20 more segments.
Mhm.
So it can be done in that way. And yeah, I think, yeah,
So basically, you can I think one more thing you can do is like, okay, fine. In the segments, in the manifest file, you can give the segments and the URLs, and maybe
Mhm.
just to optimize the URL can point back to some CDN, right, or something like that, so that the clients can fetch the data from the nearby CDN server, let's say,
Yeah, yeah.
and
So what
there should be
we,
some end marker.
we are actually downloading two things here. One manifest file, and the other thing
Yeah,
is basically the actual content.
yeah,
So both of them can be cached at their CDN. So CDN can have manifest file as well as the actual content. I mean, videos,
yeah. So basically, the
images.
manifest file communication happens through HTTP for simplicity, HTTP or
Yeah.
something based on HTTP, and your actual segment downloading, right? Uh, you were saying that it should happen through RTMP,
No, no, no. Actual
or it.
downloading can happen through HTTP only. So we don't need
Oh, I
RTMP.
see. I see. So both should be HTTP, basically.
Yeah, both of them are HTTP. And in reality,
Okay.
also, I mean, it's a HTTP based protocol only. So we don't use RTMP here.
Okay. I
So
see. So in the in that
if
way,
we, yeah, if we use
will
this
you
approach
have?
where
Yeah.
we are actually also giving the 20, I mean, we are saying that these are the 20 segments that you have to download. If we go ahead with this approach, then it's easy to know when the live stream ended, when user actually clicked on the, end live stream button. So we can basically store that information, and, that information can be propagated through the last manifest file. So if we go ahead with that approach, that problem is also easy to solve. So rather than, embedding this information in a video segment, we actually embed this information in the manifest file only.
Yeah,
Did you
basically
get my
these are two
point?
separate parts. Yeah.
Yeah,
So in the manifest file, it clearly tells what are the segments available and where it ends.
yeah,
And in the other HTTP calls, it can simply download the blobs. It can simply download the chunks from the CDNs, right?
yeah.
And can just show it on one after another, right? Yeah. I think logically this makes more sense. Yeah. But the next question is for this, would you like to have a separate servers, right, which will be actually serving these clients? So can you draw that
Uh,
portion? I mean, the clients also should be connected somewhere, right? They are not connected to a TMP server.
yeah,
They'll be connecting to maybe nearby CDNs, but CDNs also need to connect to the backend servers, right? Or the backends will be pushing data to the CDN.
So there will be some sort of step here after the pipeline, which actually pushes the data to the CDN. So we can actually, I mean, again, we can take any approach here. We can have push-based CDN or pull-based CDN. Uh, Pull-based CDN would be, user hits for a particular video segment. If it's not
Mhm.
available in the CDN, then basically it goes to the backend server, and then backend server serves the video as well as pushes the, video to the CDN. So that is pull-based. Push-based is basically as soon as the pipeline is complete, the segment is basically pushed to the CDN. So we can take any of the approach, and we can also take a mix of the approach based on the geography and all. Maybe for example, let's say if a live stream is very popular in India, then it makes sense to take push based approach. But let's say if it's not that popular in, let's say, USA, then maybe not a good idea to use push based approach there. So we could use pull based, or maybe not use CDN at all. So again, it will be a mixed approach in real life.
Yeah.
Uh,
So yeah. So the CDNs can directly talk to your backend servers, and the backend
mhm.
can fetch. But there is one more thing. I mean,
No, CDN is
the
not talking to
clients.
the backend server. CDN is not talking to the backend server. So what is happening is basically
No, no, I'm
user
saying
hits
that
the CDN. Yeah,
for the pull-based CDN, right? So
yeah, yeah, yeah.
once user hits the CDN has to ask the backend server, right? Give me this data.
Okay. Yeah, yeah.
That is the pull-based, right? The
Mhm.
CDN has to ask the server that, hey, I don't have this data. You give me this data and I'll cache it, right? Now there is one point here. How will the client know that which stream ID it is actually talking about?
Which
Um,
stream ID we are talking about?
yeah, I mean, once you watch the video, right?
Mhm.
Once once
You
the
mean
app actually shows.
when we are starting, I mean, when the user is starting the stream, starting to watch the stream,
Yeah,
right?
so in the first, so yeah, so that's what I mean. In the when you see.
So this is audience. And of course, how would audience know? I mean, what are the available streams and how does it get to know the stream ID? So for that, I mean, usually what happens is, you go to some page of the website. There you see, these are the live streams which are happening right now. So you click on that button and then it starts I mean, you start watching that live stream. So when you are basically loading that page at that time, what is happening is that data will be fetched from the stream database, and there you basically get the stream ID, and that stream ID we can basically use to watch the video. So let's call it maybe broadcast server. So I mean, this basically, or the request, I mean, a user basically, clicks on the watch button. At that time, a manifest file is downloaded. So the manifest file will be basically, it will attempt to, download from the CDN. And if it's not available in the CDN, then it will be basically um downloaded from the broadcast server. And broadcast server will basically download this from the S3. Similarly, if we are going to build a sort of mix kind of system where we are also using push based CDN, then once the processing is complete here, then we will have this data push to CDN. So we can give it any name to this server. I don't know, maybe
That a broadcast server can directly also do, right? I mean, the
yeah, yeah, that can be done, but I mean, in reality, you kind of segregate the systems into two kind of services. One which actually called talk to the user, and others which never talk to the user. They remain in the backend only. So these, I mean, the services which actually talk to the user, they are called front end services, and these for front end services can talk to these backend services, but these backend services will never talk to user directly. So in that sense, basically we should have a separate service here. But yeah, we can, I mean, it's completely up to your how you build your notions. And yeah, so we have talked about this. Let's talk about some failure scenarios. So one major failure scenario that can happen here in basically it can happen in the RTMP server. So what our host is connected to one of the RTMP servers, and so RTMP server is a stateful, I mean, this is a persistent connection. So if it's a persistent connection, there would be some information related to connection, and that information will be stored on that particular server. So, and that information is basically called as state. So, which means these servers are now storing some state. So they have become stateful now. So since they are stateful, so it's, I mean, so stateful servers are actually, they become a bit challenging when I mean, in case of failures. So uh, there are two main scenarios. One is when one server goes down, and the other is basically how do we do the deployments. So let me first talk about how when one RTMP server goes down. So let's say I have my host connected to one RTMP server. Let's call it server one, and this server just goes down. So what can happen is basically, I mean, the host can of course connect to, it can connect to another server, but the problem is state is lost here. So what do we do in that case? So in that case, what I mean, there can be two ways to deal with it. One is we try to bring the RTMP server back somehow. We might have a sort of backup for this state, whichever is basically we are storing here, and we try to either we bring up the backup, or we just somehow try to bring that server itself live. But of course we cannot, I mean, it's possible that the hardware itself failed, so that's not really ideal scenario. But yeah, we can have some sort of backup which basically stores the state. So in that case, what will happen is we will force the host to connect to the backup now. So backup will have the same I would say FQDN, or I mean, we can basically call it uh, let's just call it public IP. So it will have same public IP. So host again connects to the same public IP, which basically goes to the backup server now. So we will have to somehow force this information to the host. And how do we force it then? So for forcing it, host should store this information that it's connected to this IP address. So that can be done when host had connected to the stream frontend. But overall, I mean, this is a very complex system of handling with the failure. So another approach could be basically, we rather than having these backup servers for each server and forcing the host to connect to a single server, we can actually have some sort of global storage, um, which is a kind of cache only. So let's call it state cache. We can maybe use some Redis kind of thing here. So this Redis actually stores all these states here. So whenever the state changes, you also store that state to Redis. It's Redis as well. So
So
if
how do you
one server,
identify the states? I mean, what is the state that you are talking about here?
that is a good point actually. So we should, I mean, Redis is a key value store. So is Redis a key value store? No, Redis is not really a key value store. But yeah, basically we will have a stream ID as the key here, and in the value we will have state. So host knows the stream ID. It goes to the RTMP server. RTMP server knows the stream ID, and it says that sees that it doesn't have state in its local. So it goes to the Redis, it pulls the state from there against that stream ID, and then it basically establishes the persistent connection.
So what are the states actually? That's what I'm saying. What are the states? I mean, you are talking about the states of the chunks, right?
So state, I mean, as far as I know, the RTMP states basically also contain information like till where we have uploaded the stream, and what is the current chunk number. Those kind of things are, I think, stored in the states. But maybe I'll probably have to check in detail. But yeah, that's all I know about the state.
Yeah, the point is, I mean, the client can also store these states, right? I mean, if it's a global
Client.
storage, right? The host client, whatever app the host is using, right? It can also store the states that, hey, I have uploaded this state and this was acknowledged by the RTMP server. So if it has to reconnect back to another RTMP server, right? It can update. It can just send the next chunk, right? I mean, why are you bothering
Uh,
the backend with
yeah,
this?
that's a good point actually. So
With
it's
this,
not
yeah,
like user might resume the live stream from another device. So
yeah.
that
It's
is
going to be
something.
this. It's going to be the same device. I mean, it has no
Yeah,
connection with another device at all.
yeah. If it's
And
going to
if
be same device, and we don't really
yeah,
have any security issue here, then I think we can just store the state on the host itself. Yeah.
yeah. I mean, you don't need to actually make it complex. So rather, you can, yeah. I mean, put the state boxes to the host side, to the client side. Yeah. And even if let's say the host uploads something duplicate, that's not a problem, right? I mean, we can have the duplication mechanism in the server side,
Hmm.
that what chunks already been processed, what hash has already been stored for certain resolution, for certain chunk and all, and that should be easy to do that. So deduplication, if required, if just required, can be done at the backend side, but the state caching can be done at the client side. This is what I feel.
Yeah, yeah, we can do that. I'm actually thinking what happens, let's say if client modifies the state and let's say it was at segment number 10, but it somehow modifies the state to let's say 100. So
That
now
don't
the
happen, man. I mean,
operations will be
the
impacted.
client is also an SDK of yours, right? I
No,
mean, the
no,
client is
I mean, so a malicious user can do that, right? Malicious host.
no how
I mean, let's say
how
if
while uploading the live stream, it happens through the client SDK, right? I mean, the client side libraries. Um, so who will change the host number from 10 to 100 or 100 to 10 back?
client can do that. I mean, that's how, I mean, whatever information is on the client, it can always be spoofed unless it's protected, and unless it's encrypted and basically the key is in the backend.
So the chunk ID is completely, how do you call it? Controlled by the client, right? The incremental
Chunk
chunk ID that you are
ID
talking
is,
about.
yeah, yeah.
So, so the client can manipulate chunk ID also, and then the TMP server will also get the wrong chunk ID. That will also break the system, right? I mean, if it is chunk 10 and the client sends it as a chunk 5 again, you're probably going to
Mhm.
discard the chunk, or you're probably going to overwrite the previous chunk data, something like that, right? So that also breaks the system.
Yeah, yeah.
So yeah, so I mean, your data will be anyway, let's say, encrypted. I mean, whenever you're
Mhm.
you are live streaming, your video streaming data will be anyway encrypted, like WhatsApp communication or Messenger communication, for higher security. If you are just concerned about that, right? But I think the chunk details are anyway controlled by the host for simplicity, and there is no way to know for the TMP server also which chunk is should be given what number, because the chunk can be just in another case, in another world, if the chunk is actually parallel. I don't think so any parallel chunk will be there, but I think it's better to give the control of the chunks to the host only, and the state to the host only, assuming that there is enough security.
Yeah. I think we are going in too much low level detail. So, but yeah, basically these are the approaches that we can use. So we can basically, see whatever works in, real system.
Just ship the box of state cache to the host set for now, so that you don't lose
Uh,
the track here. Yeah. Yeah.
okay. So we have talked about fault tolerance here. I think one thing that we didn't talk about is deployment. So the deployment actually becomes really complicated when you are dealing with the stateful services. So let's say I have some code changes which I need to deploy to RTMP server. So how do I do that? So if we have stateless services, stateless servers, then what you do is basically just stop the traffic to those servers, and you deploy your code and then you bring them back into pool. But for the stateful servers, the problem is you need to basically, I mean, you need to either wait for all the connections to disconnect, which
Mhm.
is basically called draining the connections. So let's say I have 10 connections connected to my server and I need to deploy my code. So I'll have to either wait for all the connections to disconnect, then I go ahead and deploy. So meanwhile,
Mhm.
I'll stop taking any new connections. That is one way. Other is I go ahead and disconnect all the connections. So then all these 10 connections will try to connect to another server. So, but the problem is when you are in a very high scale system, this can
Mhm.
actually bring a lot of new traffic to the new servers, and this can be problematic. So if you force all your connections to disconnect and go to some other server. So yeah, that's where basically the complexity lies when you are dealing with the stateful servers. Uh, so I think in reality, what happens is uh, you kind of yeah, I think what Netflix does is it starts. I mean, it starts draining out the connection. So it basically what it starts disconnecting the connections, but it doesn't do all of them at once. But I mean, it takes time. So
Mhm.
it will basically, let's say, disconnect maybe let's say 1% in first minute, and then it will keep disconnecting slowly all of them, and then
Mhm.
once all of them are disconnected, then it will basically go ahead and deploy. I mean, that is just very high level idea of how it's done, but yeah, it's a little
Okay.
more complicated than that. So yeah, the we have talked about failure at the RTMP server. What else is pending?
You also sometime back talked about the different kind of failures maybe in the processing pipeline, right? To store the interim data and all, right? So okay, so maybe there may be one failure in the S3 servers, or the even the internal block storage. I mean, you put the RTMP service data to S3 server and put a message to the message queue, right? So are these steps transactional? Or what if, let's say, uh, there is a very minuscule chance though that writing message to Kafka will fail, right? But if there is a huge load suddenly,
Yeah.
right? How will you scale Kafka? I mean, you are pushing a lot of messages to Kafka, right? So will you use single topic? Will you use multiple topic? How are you going to decide that? Because there are going to be a
Uh,
lot of chunks at this scale,
mhm.
at this millions of scale, right? Assuming there is some event happening, let's say football somewhere or cricket, and a lot of people are live streaming, or some event is like Diwali happening, and all of the people, let's say from India, are uploading some video, maybe in the same time. How will you s- how will you choose topics in message queue?
So let's say we can assume that our Kafka is partitioned on the basis of should we partition? Yeah, I think we'll have to partition it on the basis of stream ID. So let's say it was partitioned on the basis of stream ID, and now there is, let's say, sudden search. So what can happen is uh,
Partitioning stream ID is it a good choice because your stream ID is going to be unique for a video, right?
yeah, yeah.
So
So then all of the segments will fall in the same partition.
yeah, now let's say that
Yeah, I
okay,
mean there
so
can be a sort of hot partition issue. Uh, so let's say
no,
if
I mean,
one is
yeah, are you going to
uh,
make some hash out of this stream ID, or your partition ID is the stream ID itself? I mean, the or to put the question in another way, is your partition going to get data from multiple streams or not?
I mean, it doesn't matter really here. So we don't really need any strict partitioning here. So what we basically need is anything which basically distributes our load evenly. So I think we can take a hash of the stream ID, and then basically on the then hash might become the partition. I mean, sorry, partition key.
Yeah.
So on that basis, I think it will evenly divide the load. Because hash is basically random, so
But is it going to be single topic? Because I mean, are you saying that the topic is one topic and there are multiple partitions? So is there any way to add partitions to an existing topic on the fly?
on the fly, can you add partitions?
I think you specify partition when you create a
I
topic.
don't think so. I think
When
you will
you
have to stop the whole system, then you can add partition.
Yeah. So with a high surge of events, it will be a little difficult, right, to scale it
Yeah, yeah,
with a
yeah.
single topic.
Yeah, so in that case, since our partitioning is based on, it's basically on the hash. So essentially, we cannot increase the number of partitions here, but what can we do? One way is to basically allocate another topic if we have for really popular events. So what we'll have is basically we'll have essentially additional the whole whole new infra for the popular events. So we have new topic for the popular events, and then obviously processing pipeline will also will also have to see there. What else can we do?
I think, okay, what about having just, I mean, anyway, before, what do you call it? Uh, Before even having number of topics, right? You'll have some estimations anyway that what is the maximum number of users you can assume, right, from certain regions. So anyway, region basis traffic can be there. But importantly, you can have, say, few number of topics already warm up, right? And the messages can actually go to any topic. I mean, let's say you have n number of topics with m number of partitions, and it really doesn't matter, where the messages actually end up, because your processing pipeline will anyway take the data and process in the same way, and then insert into the DB. And from the DB, it matters from the DB, you know, from the metadata storage, you can actually see how many actual chunks are there for a given stream ID, right? So for that matter, the message queue and the processing pipeline, that communication doesn't really matter how many topics are there, or it even doesn't matter that the same stream ID that actually goes into the same partition. It actually doesn't matter because there is no ordering requirement in the processing section, but there is ordering requirement in the pushing to the CDN section, right? And that will be served by your whatever the DB metadata, video chunk, DB metadata, whatever is there, right? That knows that what is the chunk ID in order for a given stream and what are the stream URLs or what are the URLs for a certain resolution, right? So I think after the estimation, we can have n number of topics. The n can be 3, the n can be 5, I don't know, but there can be multiple topics warmed up, and then maybe say m number of partitions in each topic. That will also depend on the estimation, and the messages can be gone to any partition, right? And the processing can happen. That's not a problem. To me, what do you think?
Yeah, makes sense to me.
Okay, I think let's cover just one last thing. Or this video is going on and on for some time. So can I just wrap up? Can I just check the API section and wrap it up if there is anything to do in the API section?
Our first request was basically stream ID. We were basically creating a stream, so we can just have a post call to slash streams, and then
What are you going to
we are
send
also
in this? What are you going to send in this post call at high level?
high level. I think we should be sending what is the format? Should we do we know the
No, no.
format?
You don't know the format, right? You don't need to know the format. The system can identify the format, the source format.
Mhm. Yeah.
Right.
So
I mean, you just want a
user
stream
ID.
ID. from the stream front
Yeah,
end. So what does the stream front end essentially gives you? It just gives you the stream ID, is it? And create
yeah,
some metadata entry maybe if required.
yeah.
Okay, so it can be empty body, I think.
Yeah, I think we can send empty body. I mean, we need a user who is basically starting the stream, but that can be figured out from the login token or cookie. So
Yeah, I
body
think
can be
we don't send user ID in the post request body. It should be part of some security context or maybe the header. Uh, yeah,
yeah, yeah.
or maybe
Then
some token. Yeah.
yeah, so then I'm assuming that I mean RTMP also requires an API. So it will probably look something like we are sending chunks here. So we are kind of creating segments. So it's a sort of post call to the segments API, and in the body, actually, so segments is a sort of sub resource of stream. So it should ideally look like stream slash stream ID slash segments. So we make a post call to this API, and in body we have the video which we are sending. Then audience will be making two kind of calls. One is both of them are kind of HTTP calls. One is to the manifest file, so it makes a get call to manifest file. So manifest is a sub resource of stream. So it knows the stream ID. So stream slash stream ID slash manifest.
Mhm.
And in manifest, if we had taken the second approach where we had to periodically download the manifest file to get 20 segments at once, so we also need kind of need the manifest number in that case. So in that case, we can either put a query parameter here or path parameter, doesn't matter really. So maybe manifest number. The manifest number is, let's say, 0. 0 means first. Then similarly, when we are downloading the videos, so we will be basically buffering the videos, which means that we download 4 or 5 segments at once while user is still seeing the first segment only. But in advance, we are downloading 4 or 5 segments at once so that user doesn't feel any lag when we are actually downloading the video, videos. So now for that, we can either download, let's say, 4 or 5 segments at once, or we can make 4 different calls to the backend to download these segments. uh, I would say it should be flexible. We should have both kind of APIs, and we let the client decide how it wants to download. If it wants to download in bulk, then that's also fine. If it wants to download
Yeah,
one
yeah.
at
I
once,
mean,
yeah.
yeah, that is fine. Yeah.
So there also it's basically stream slash stream ID and slash segments. Here either we can have segment ID or as query parameter or path parameter. So I'll just make it a path
Mhm.
parameter. Yeah, so I think we have covered pretty much everything.
Do you left
Do you
anything
think
in the
any?
to do section? Do you have anything left? How to avoid multiple downloads and dependency on S3? Yeah, I think we talked
So
about it.
S3 dependency on S3, we have talked about it, having a in-house blob storage. Ordering of chunks is already covered actually.
Yeah.
How to avoid multiple downloads. Yeah, I mean that is basically the same thing here. Having an in-house store, I mean that means we don't need to download files multiple times. So yeah, I think we have covered up.
Yeah, I think I will cover most of the part. Yeah. So anyway, it's a long discussion. Anyway, there are still areas which you can go inside into. Right, but I think for this video, it's fine. If any response comes from the audience, we'll try to address them. Yeah. Right. But yeah, I mean, Yeah, it looks good, man. Yeah. Thanks a lot for your time, Karthik.
Yeah, yeah,
We'll
thank you.
collaborate on the next video too. So I'll stop the recording for now. Yeah.
Sure, sure.